In our last video, we learned how to graph the basic quadratic function y equals x squared. So what we're going to add this time is how do we graph functions that have things called translations. So first of all, let's do a couple examples to see what these things look like. So if we do y equals x squared plus 3, or y equals x squared minus 4, what do those things look like? So what we're going to do is we're just going to extend our t-chart that we made in our last example and add each of these functions. I guess I'll do them in different colors. Let's do this one in purple. This is x squared plus 3, and this one will be x squared minus 4. So if you follow order of operations, we're going to take our x values, square them, and then add 3 to them. So this value here, 0 squared is 0, so 0 squared is still 0. When we add 3, we get 3. 1 squared is 1. 1 plus 3 is 4. 2 squared is 4. 4 plus 3 is 7. 3 squared is 9. 9 plus 3 is 12. And similarly, so each of these points here, we're going to add 3 to the value to get the symmetrical 4, 7, and 12. And then this quarter, this is 3 1/4, and this is also going to be 3 1/4. So if we graph this then on the same axes as our existing y equals x squared, our original point, instead of being 0, 0, now the x value of 0 gives us a y value of 3. So 1, 2, 3, we put our first point. And 1 squared is 1 plus 3 gives us 4. So our next point is 1, 4. And then our next point is 2, 7, 2, 4, 5, 6, 7, and then 3, 12. Well, this is 9, so I need to actually be 1, 2, 3 higher. And that's actually the other way you can think about this. All of these points in our original function are actually 1, 2, 3 points higher than the original points. So I can actually do it this way as well. Take my original point and go 1, 2, 3. Take this point, 1, 2, 3. Take this point, 1, 2, 3. And there we go. We have shifted all of our points up by 3. And then this point here is going to be a quarter box and a quarter box. And there you go. Once we connect all of these points into a nice flat-bottomed parabola, we get y equals x squared plus 3. So if plus 3 meant that we shifted 1, 2, 3 up, what's minus 4 going to do? Well, sure enough, our guess would be probably, instead of going up vertically, let's go down vertically. 1, 2, 3, 4 points down. This point, 1, 2, 3, 4 points down. This point, 1, 2, 3, 4 points down. And let's check with our table of values to make sure that's correct. So 0 squared minus 4 is negative 4. 1 squared is 1. 1 minus 4 is negative 3. So 2 squared is 4. 4 minus 4 is 0. 9 minus 4 is 5. So by symmetry, we're going to get negative 3, 0, and 5. At this point, we probably don't need at this point. We know it's sort of going to be a quarter box up from our vertex. So this point here is 1, 2, 3, 4 down. This point here is 4 down. This point here is 1, 2, 3, 4 down. 1, 2, 3, 4 down on this side as well. And so we got to point a quarter box up, and there we have it. This here is y equals x squared minus 4. So these are called vertical translations. So this plus 3 meant it moved up, sorry, not y, it moved up 3, and that negative 4 meant it was down 4. Okay, so that's our first type of translations. Our next type of translations are a little bit trickier. And let's go through these very carefully and slowly. So we're going to investigate y equals x plus 2 in brackets squared. So let's go through and build a t-chart for this function. Okay, I'm just going to skip fraction values. Let's do our sort of usual 0, 1, 2, 3, -1, -2, -3, and see what happens. Okay, so our 0 here. 0 plus 2 is 2, and then 2 squared is 4. So let's actually go through. 0 plus 2 squared is 4. 1 plus 2 squared is, 1 plus 2 is 3. 3 squared is 9. So 2 plus 2 squared is 16. 3 plus 2 is 5, so 3 plus 2 squared is 25. That's interesting. 4, 9, 16. Well, 4 and 9 I recognize. 16 would be our next point here, right? 4 squared is 16. And sure enough, 5 squared is 25. So if we kept going, we would get these next 2 points. So let's work backwards and see what happens. -1 plus 2 squared. So -1 plus 2 is +1, and +1 squared is 1. -2 plus 2 squared. Oops, sorry, that should be squared as well. So -2 plus 2 squared is 0. 0 squared is 0. And -3 plus 2 squared is -1 squared is 1. I feel like I should have added more values here. Let's add them down here. -4, -5. What are we going to get? -4 plus 2 squared and -5 plus 2 squared give us -2. -2 squared is 4, -3, and -3 squared is 9. So there we have it. Our 0, the 0 of our function, the bottom point of our parabola, is actually at -2 now. And our 1s are at -1 and -3. And our 4s, right, we got those from our 2 squareds. Our 2 squareds are now at 0 and -4. Okay, let's graph this and see what it looks like. Okay, so this is x, and this is y. Let's do our basic parabola just in blue. So 0, 0, 1, 1, 2, 4, and then 3, 9. Okay, so this is our basic y equals x squared parabola. Y equals x squared. So now what we're going to do is we're going to graph y equals x plus 2 squared. So -2 on our x value, on our x-axis, gives us 0 on our y-axis. -1 and 1 is a point, and -3, 1 is a point. 0, 4 is a point. 0, 1, 2, 3, 4. And by symmetry, you see how this is sort of symmetrical across, our blue function symmetrical across 0, 0. This function is going to be symmetrical across our vertex down here. And then our next point then is going to be 1, 9, 1, 9. And then our other point is -5, 9, -5, 9. So there we have it. This is y equals x plus 2 squared. So let's try another one. What about y equals x minus 3 squared? So this plus 2 made us move 2 to the left. Maybe this minus 3 is then going to move us 1, 2, 3 to the right. So maybe our guess would be that it looks like this. 3 to the right, and then our sort of basic parabola shape. Over 1 up 1, over 2 up 4, over 1 up 1, over 2 up 1, 2, 3, 4. And then this one's going to be sort of off our graph here, and this one is going to be right here. So that's my guess. So why don't you pause the video right now and try to build a table of value for this. Build a t-chart, x, and y equals x minus 3 squared. And to check out these values, you're going to need to use 0, 1, 2, 3, 4, 5, and 6. So 0, 1, 2, 3, 4, 5, 6. And see if you get this graph. Okay. Sure enough, that's exactly what you get. You get 0, 1, 4, 9, 1, 4, 9, and it exactly matches that function. This brings me to one of the most confusing parts of this course, learning quadratics for a lot of students. Why does plus 3 shift us to the left? And why does minus 3 shift us to the right? So the reason for this is, imagine we're trying to get our y value of 0 out of this function, right? Imagine you want to get 0 out of this function. The only way you can get 0 is by squaring 0, right? So what's the value of x, say in this equation, that would give you 0 squared? You need positive 3 to be 3 minus 3 gives you 0 squared. And over here, you need negative 2 plus 2 to get 0 squared. So in other words, x essentially needs to compensate for what's being done to it. If you're trying to minus 3 from x inside the brackets, to shift back to being 0 squared, x needs to do the opposite. It needs to do plus 3. If you're doing plus 2 inside the brackets with x needs to do the opposite. X needs to do minus 2 to compensate, to get back to 0 squared. So I tell this story, you can sort of think of these brackets kind of like the dojo. And x is in the dojo with this negative 3. And that means that x is always about the yin and the yang. Whatever is done to x is going to do the opposite, to compensate. Okay? So minus 3 to x means x is going to do plus 3, which is why it's 3 to the right. Inside the dojo with x, we got a plus 2. So what's the yin to the yang of plus 2? Well, the inverse of plus 2 is minus 2. So x is going to minus 2 to compensate. And in our next video, we're going to learn how to put these two things together. We're going to learn how to put these vertical and horizontal translations together.